Okay, Bismillah. Let's start with these tasks of the lab 6 about this recursive. Now it says write a program that reads an integer n from the user and then prints all even numbers between 0 and n. The program must include a recursive method. This is the name and the heading that does the printing. So I'd like to create this, and then what I'm going to do, I'm just going to open this one. And let me have a look at what we have. Like we have this test, wherever. We can just copy one of them maybe. Now this is the one that we've been working on, where we did this factorial non-recursive one, but I just copy and paste, because I would like to benefit from all the scanner and everything. So I'm going to call it test recursion, because I'd like I'm going to test lab 6. That will be much okay, so test lab 6, and then what I would like to do is just to remove these and then just add the ones that I'm interested in. So I'm going to also remove this one, and we'd like to copy and paste. So we'd like to do this kind of recursive print. So I'm not going to put that in a system.out print line, but what I'm going to do, just call it. So I'm reading a number, so, and then I print all even numbers from 0 to whatever, to that number. Enter a number. And then I can display something like all even numbers from 0 to this are, and put n r, and then do something like this. So now, yes. Yeah, yeah, sure. Thanks. So now I need to print from 0 to that number. So in order for me to do that, I need to call this recursive print with some kind of a way, but then I need to do what? Because this is going to print, let's say, I'm going to, if you give me n, I'm going to print n minus 1, like in the same style that we had, like the factorial or the other one that we have seen. And then, well, but I don't do that all the time. What I'm going to do here is have some kind of if, actually an if else, right? So if the n is equal to 0, reminder, no, because I'm displaying from 0 to n. So well, I would like to put a condition where to stop. So where am I stopping? So
higher than the end.
Well, it depends what you do. How do you where do you start?
I start from 0.
You start from 0, and then how do you start from? You make a loop then? You need to start from n and try to go down.
Oh yeah, I'm thinking of that.
So now when you do something like this, now this is when I'm going down, I'm going to the minimum, I mean this anchor thing, the exit point here is the where it's 0. And then when it's 0, what should I do? I'm going to print 0. And I'm going to put maybe something like this and put a space. Or maybe, you know, because I know it's 0, it might be better to do just this. Sorry, Qasim?
If I say there are no even numbers between 0 and 0.
But at least 0 is an even number, right? So if it's something else, I'm going to say whatever, if it's a number negative, actually that's a good point, if we can deal with the negative number. So if I'm going to put this as an else, and I'm going to put here an if what? If the number is negative, so I don't need to even do anything. I'm going to print nothing. Nothing to display. Something like that. Whatever. So if I'm dealing with the case when it's negative. So if it's negative, there's nothing to display, and that's it. Else if it's 0, that's where I'm going to stop. Because so if now the n here, for example, is negative, I'm going to get here and I get out. Now if it's 0, I'm going to display 0 and put a space. Else, well, I need to have else if what? If it is odd or even. Here inside I need to put some kind of condition. Now if I'm here, that means I'm not 0. Now in a position when I need to decide if the number is odd or even, right? I can put it else if, but I just want to organize things like that. I mean, this is the first condition that makes us just exit. The second condition that make the recursion stop. Now this one, if I'm in the else, I know that now I'm going to deal with the number being odd or even, and if they're even, then I'm going to display them. If they're not odd, I'm not going to. So it's at least it's an else if, but I just want to make it clearly separated from those. But I'm going to go back to the else if. So now if the n is, if modular division by 2 is equal to 0, then so that's what I'm going to print. Print what? Print the n?
Yeah, and then the number that's listed by 2 minus 2.
Like n like this, and then put a space, something like that? Okay, and
N minus down, yeah, minus 2.
and minus 2. And else?
Else n minus minus.
Else n minus minus?
Yeah.
What do you mean n minus minus?
Because if n.
I'm going to decrease by 1?
Yeah. If it's
I mean, you're talking about this one?
no. Leave it. I mean, if it's
Like
if we
this?
put- yes. If we put like 21, all conditions are wrong. Then make it 20.
Okay,
After
I
20, every time it's gonna be right.
I get that, but the problem is, you should not just do only this. Why? Because there's no loop here. Now, for example, if you say 21, right? 21, this is false, I go here, 21, this is false, I'll make it 20, and then I stop.
No.
No,
Then I
write the method again.
write the method with n.
Now this one,
And
recursion with n,
Yeah.
right? And then, now this makes it a loop. Now, once it's n minus 2, because
It's gonna always
We need
go
to
to
print the n after we decrease it.
we need to print
The n after decrease.
after decrease. I mean, if we print here, we're going to print, let's say,
Even.
21, let's say 20, because now it's an even. I'm going to print 20, then I'm going to see how to print 18 and then 16. So I'm going to not from 0 to n, but from n to 0. So if you would like to have them in the opposite direction, I'm going to print this only after I finish going all the way around to the last one. So for example, if it start with 20, or let's start with an easy number so I can not repeat too many times, like 6. 6 less than 0? No. Equal to 0? No. 6 is even? Yes. So now call it with 4. So this is not finished yet. Once I've finished all this, when it is gone, not going to be any more recursion, I'm going to print 0, and then I'm going to print 2, and then 4, and then 6.
So you're gonna sort print from 0 up to.
From 0 to 6. If I move this around, if I move this up, that means before going for the next iteration, okay, put the number. That means I'm going to see 6, then 4, then 3, then 2, then 0.
Of course, you ask to print it from like the highest up to the lowest.
Did it?
I think.
It says between 0 and n. You must probably there's nothing like that. Maybe this is the reverse one that's going to print them in the reverse one. So now, is this enough? Let's test.
We need to put something to print.
Yes, we need to put something. But let's see. Okay, that's not what I want. Why did I okay. Okay, we have this test print odd and test print reverse. I did not look at that, but anyways. Let's just shift F6 so we just need to run the file. So we enter a number, let's say 6. All even numbers between 0 and 6 are 0, 2, 4, 6, which works. The only maybe thing that I need to do, once I reach like this, maybe I don't know I need to put some kind of system auto print line. Here, it's the easiest one, is just here. Okay, something that is waiting for me. Okay, lab 6 run. I'm just running this one. I'm going to stop it. So now, what about shift F6 and then I put 7. So I don't need to do anything else. So if I do this and then print, I'm going to print something twice when it's even, because I'm only printing here. I'm just dealing with the case where it's just even, and this is what I'm going to print. If it's odd, I'm just decreasing by 1 and calling the 1, so I'm going to print here. So now, actually I don't need to put it like this. It could be just if, else, because it's a chain anyway. And that's going to work as well. Just doing this all the time. Shift F6. So now, if I put 3, it just goes that, and Shift F6 again. I put, yeah, let's try with the minus. Nothing to display, and if it's 0, so this is 0. And this actually from, that should be much better, from 0 to whatever. Yes. Can I do what?
E-bag for the even.
E-bag? Don't know what you mean.
The thing that we
Do what?
to show us the step.
The debug.
Yeah.
Oh. You want to see the steps? Okay. So what I'm going to do, I'm going to, let's say I'm going to click here and then click on the, no, not again, because it's going to take me to this one. So this is the debug key control, right click here, the debug file, which is control shift F5. Now it's going to take me this, let's put 4 or 3, let's put 4. Now with this 4, I'm going to put this here so I can watch the number decrease. And now F7 is what I'm going to use because I'd like to get into, but not all the time, because if I use F7 inside here, it will take me inside the println. So sometimes I'm going to use F8 to step over. When I want to get inside, like here the method, this one, I will use this button here, step into. So I'm going just to use now this one. Is it like this? No, it's false, false. Now this is true. I get inside now. This one I don't want to execute with this one, because if I do, I will not get into the recursive print even. So I'm going to get into this one. And now see I'm calling again, but this time I'm calling with n equal to 2, because 4 minus 2. And then I'm going to go inside again. Now, is it less than 0? No, I don't need to. Is it? I mean, anyway, even if I use this now, it's not a problem. Is it even? Yes. Now it's going to be 0. And then now if it's negative, no. And then if it's 0, which it is, I'm going to print just 0. and you can see the stack now is going to be decreasing. And now this is going to print n when n is 2, and then it's going to, I can also do something. I can just go for the output and put it here so I can see them at the same time. Okay, I need to fix them first. And yeah, I can see the output like this. So now you can see now this is going to, I mean, it's already done. So it's already done, but it's printed just one by one. So that is this one. Now the recursive reverse print evens is almost exactly the same, except that I need to do something differently. Is I just put this after, and that's it. Just by switching the order. Now if I call this one instead of from this to 0, from n to 0 r, and then let's run. You know what? I'm going to click on this, go to the properties, and then in the run I'm going to make not this one as the test. The default one is going to be this one for me, so I'll just don't have to just click here. It will run this one now. Now if I print 4 now, I'm going to see 402. Not really what we expect. What is the problem? So when it's 4, this is false, this is false, this is true. I display 4 and then make it 2. And then this is going to call it again with 2. 2, false, false, true. I display 2. And then to make it 0, false, true, I'll print 0. So then after I print 0, I stop, because it's going to print the 0. But why do we have this kind of output? To know that, let's just focus on doing the debugging again. So now it's just waiting for me to enter a number. I'll say 4. Now is 4, okay, from 4 to 0. Is 4 less than 0? Yes. Okay, sorry, less than 0, no. If 4 is equal to 0, no. Is 4 even? Yes. I'm going to print 4. And this is 4. Then I'm going to call it again with 2. So, oh. I didn't get the I pressed F8, and that's what, when I pressed F8, that means I just stepped over and then did not get inside, so that did not do whatever I wanted to do. Now run it again with 4, and I'm just going to press on F7, okay, except for this one. Now this I'm going to, now it's going to be n, it's going to be 4, so I'm going to call it again with 2. So, do you see the problem? Do you see where am I now? We updated this, but we did not update the call. We're calling the recursive print even, not the recursive reverse print even. This is not like what we wanted to do. So we found the problem. The problem is just call the same one that you're calling, and it should be working, inshallah. Now 4, I'll get 420, and just need to, so we need to be careful about what we, when we copy and paste, just to copy and paste correctly. So we finished the 2. Now write a recursive method called multiply that takes two numbers, that computes and returns the result of multiplying m and m without using the multiplication operator multiply. Test your method by calling it in the main. Okay, so now I'm going to create a new one, this one. So we don't want to use the multiplication. So how can we not use the multiplication? We can add. So 2 times 4, it's 2 plus 2 plus 2 plus 2. So that's what we're going to be doing. And I think I can turn this on. If you think it's cold, just let me know. Okay, so we need now two numbers. Please enter two numbers, and we're not going to elaborate that more. We just need the two numbers, so m and n, and then we got these two numbers, and then we're going to say m multiplied by n equals, and that's going to be enough for us. Now I just would like to have to maybe put this as a result. How do you want to do that? I mean, to print or just to make it return? We need to return, so we don't have like a lot of options. So we're going to call this multiply n m, and let's remove this one. So now how are we going to do that? Same idea again. We need to put these two different conditions. So if else if that's what I meant. If else if, okay, okay. So if what?
N equals 0.
Yeah.
I'm sorry?
N or
N equals 0?
or n equals 0.
Or?
Or n.
Or m equals 0?
0 will give me 0.
We'll get to 0.
We return 0?
Yes.
And then?
If n equal 1 or m equal 1, then give the another number.
What do you mean? I'm going to put if n is equal to 0, do this. If n is equal to 1, do this. If n is equal to 2, do this. So else what?
If n, because we have the negative and positive, right?
Yes.
So we can do if else if n is negative.
Now we just multiply. We don't do the power, right?
Yes.
Which means, like, if we call multiply with 2 and 4, what we're going to be doing is 2 plus 2 plus 2 plus 2, which means 4 times. Now how do we know we do this 4 times?
We can make the n the number that we add, which is going to be.
So like this one,
On this one, we increment it every time we do the recursion.
so we increment it or decrement it, you mean?
Increment it, right.
Because increment we're going to increase. We don't want to increase. We'd like to say like 2, 4 is actually 2 plus 2, 3. And 2, 3 is 2 plus 2, 2. And then 2, 2 is 2 plus 2, 1. So actually when this one is equal to 1, this is we should stop. Or there's another way around. When you make the n decrease, you can make the n decrease and say, okay, this is not equal to this, but this is equal to 4 2 times. So it's 4 plus 4. That's going to give me the same idea. But then it's 4 2 times, which means it's 4 plus 4 1 time. So I need to decrease one of them, not both of them. One of them needs to be decreased. And let's say we're going to decrease the one on the right, the m. So we are going to be in the case where we're going to be doing this. So our stopping is not at 0,
That's one.
it's at 1. And it's not about one of these. So we said this is going to be the M for us. So we are going to focus on the M. And this is the one that we're going to make it. If it's equal to 1, we return the N. Because if it's 1, I'm going to return this one. I'm going to return the N. Obviously there are different ways, but I'm just trying to show you this different one. I don't know what kind of way you did it, but let's just go from this. If it's 1, let's say if I do this, something like this, what should be the result of that? So I need to return the 2, not to return the 0 or any other value. If it was like this, 7 and then 1, I need to return the 7. So whatever N it is, I'm going to return the N when I reach M to be 1. So now if it's not like that, what I need to do, I need to return the N plus multiply with N and M minus 1. Is it enough? Yes, but what if this one is negative? Now if the M is negative, if this one is negative, we don't care because it's just going to multiply this add this many times. Minus 2 plus minus 2. But
this one won't stop.
this one will not stop. But hold on, if it was minus 2 3 times,
It's gonna make it
minus 2 plus minus 2 plus minus 2.
so it's going to be minus 2 plus minus 2 plus minus 2. So it works, right? No problems.
But if we have the opposite sign, it won't.
So if this one is positive, negative, it doesn't matter.
Yeah.
But what about this one?
It won't work.
No, this is going to be an infinite loop for us.
Yeah, infinite loop, and it won't work even if you.
It
change
will.
to,
So how can I deal with this?
You should put F before.
you flip this. You make the N negative and the N.
Exactly. At the end, I just would like to have this. The result should be negative, so I can just take the sign from here and put it into the 2. So I'm going to put some kind of condition that says that if this M is negative, then N is equal to N multiplied by minus 1.
And same for N.
And what?
Same for the N. For the N.
No, if the N is negative, we don't care. We don't touch it.
Teacher,
We leave it as it is.
you are doing all
It's gonna
that.
be infinite loop.
I'm sorry, I didn't get it.
But now it's gonna be infinite loop because infinite.
But now there's no infinite loop. This is not a loop. Now if this is going to do and then it will stop, I need to return something. So what am I returning? Because each one of those cases, I need to return something. So what am I returning here? Yes.
Teacher, we are in this method because we don't want to use the multiply. So why you put N multiply minus 1?
Okay. So what do you want to do?
Minus N.
What?
Minus N.
Like this you mean?
Yeah.
Okay, fine. But I mean the question was
So
yeah. The question is the multiplication not be using this, but you're right, because actually it says without using this operator, but the operator is meant not to use it in the multiplication, not use it in other things. It's not. But yeah, if you want to be safe and see it's possible, there's an option. You can do that.
You should change M to
You can also, if you don't want to do that, if you don't know about this, you can just make it if N is negative, then you make it positive. Then you're going to call it again with positive. Anyways, I'm just let's see, this is working. I just don't want to change that much. So now N becomes negative, or if it was negative, it become positive. Then I need to do what?
change the M to positive.
What?
Change M to positive. We stuck here because M negative.
Exactly, because M is still negative. Now I moved this. I need to move the sign, not just leave it like this. I just did this now.
Yeah.
I need to remove the sign from here, which means I'll do the same with the M. And then what should happen? What am I returning? Return M? No. I'm not returning N. I need to call again.
Yeah.
I need to call again, but this time without this -1. Because I called it with, let's say, like this. And here, I'll make it call now to be. I'll change the call to be this, and then when I call it, I'm going to call it with this now, like I'm which will make my thing work the same way I want. So I'm just using one iteration just to make sure that the values are respecting whatever I'm looking for, and then the next one is going to be working the way I'm expected to be working.
They both minus it to change them to
Even if it is both minus, it's not a problem, because both minus becomes a plus, so this is going to be -2, which will make it +2. And now we have something. And just, this is okay, but for the sake of like having organization, I prefer to have it this way. Why? Because I would like the anchor to be clearly visible. Now where we stop is clearly there, not inside the codes or hidden between some kind of codes or some lines of codes. So I see now this is where I stop, and here it's some kind of different kind of repetitions. It's the same idea, but just I prefer this way. So is it enough? Do we need to do anything else?
Yeah. What if n is 0 or n is 0?
What if it's 0? Now, if it's 0, this is not going to be false, and then it's going to. Which one is 0, by the way? The M.
N or n?
So now, if this is 0, then
You return 0.
I'm going to return. I need to return 0, but actually what happens is that this is going to do what? 0, false. So I'm getting here, and I'm called to do 2 plus 2 minus 1. And then this will make it
Infinite.
infinite. No, this will make it positive.
Yeah.
So now it will be -2, and then the 0 is -0, the same thing.
-1. It will be.
And this it was -1. You're right. It was -1.
It will become 1 now.
So it will become 1,
And then you're going to stop with -2.
and then it's going to stop, and the result is going to be
-2.
no.
2 plus -2.
Let's try it again. So this is this one. No, M is 0.
Yeah.
False.
Oh, 0.
So it's going to be 2 plus
Yeah, -2, so it's going to be 0.
-1 no, 2 minus 1. Now what I'm going to repeat again is going to give me false, true. So this will make this become here,
Yeah. Change it.
and then I'm going to call it again. When I call it again, is M is equal to 1? Yes, I'm going to return -2, and then it will stop. So at the end it's going to give me 0, which what I want, right?
Yes.
So I don't need to do anything. So if it was 2, 0, it's going to give me 2, -2, and 0. But I can do something, because I know if one of them is 0, the result is going to be 0. So I can just say if, now this is the one that you were talking about, M equals 0, then I'm going to return 0. So now I have two ways how to stop. Either if you give me one of the numbers that are 0, I don't need to do the recursion and do anything, just stop right there. Else, I'm going to check if there's some kind of, it's 1, that means either I'm going to stop, or. So let's try that now. Run 2 and 0, this is like the case we'd like to test. It's going to give us 0, and let's run it again. And 2, 4, that's 8, 4, 2. That's not the 8. And then what kind of cases we'd like to test?
4, 2.
Yeah, well, minus 2, minus 2, minus 4.
Minus 2, 2.
Minus 2 and 2.
And both minus.
And if both of them are minus, minus 2, minus 2, it's 4. So it seems to be working. Alhamdulillah. Now, let's find the minimum in an array, and then, okay, so let's just find that. So we have an array, and we'd like to, we don't need the scanner now. Well, can leave it, but we don't, I'm not going to be declaring them as a scanner because I'm not interested in doing that. I'm just going to declare my array and put the values myself. And so let's declare the array. Let's say int array equal 1, 4, 3, 2, or well, something like that. And then we would like to call this one that finds the minimum, and then we'd like to do what? Return the minimum, or what do you like when you find the minimum? Display the minimum? What is the easiest way to do that?
Play.
So in the main method inside an array we find and call a method to find the minimum and print it. So we can remove this one. Now I would like to do something like this. The minimum is, and then do some kind of minimum and give it the array. No, like this. Now there is no minimum. I need to declare it. So public static. Why static, by the way?
Because it's in the main.
Because I'm in the main. So I need to so now this array should be has a data type, and then I need to return something. But what am I returning? Okay, how do I make this first like recursive? Instead of what? Now, for example, how do we make a recursion? Now, without doing the code, like manually, how can we recursively find the minimum in an array?
The for loop.
With a no, without a for loop, because if we use a for loop, there's no recursion.
No, I mean, usually we do it with the for.
Yeah.
Now
So now with recursion, how do we solve that?
The minimum equals the first element, then we check element by element. If the minimum bigger than this element, we will let the minimum equal the element.
But I'm talking about recursion. Now this is the
Now
for
we
loop,
can
right?
Study that.
Oh, is that so? Okay. So every time there's an exercise, we are here to study it. I mean, you just give me the answer and that's it. That will be the end of it. Now, let me give you an idea. Finding the minimum is in 4 will be easy by doing it incrementally. I can just, let's say, find the minimum in the 2. Once I find the minimum of the 2, I can define the minimum of the 3. And then I can define the minimum of the 4. So that's the one way to do some kind of recursion. I can call find the minimum. So if my array was just like this, then it's kind of easy. Check the first one compared to the second one, and you get the minimum. Now once you get that minimum, we need to compare it with the third one. So now we compare. It's like finding the minimum in an array of 3 now. And then once you find the minimum here, we compare it again with an array of 4 and things like that. So that's the idea. And actually, here it gives you some kind of hint. It is similar to add array. Have you checked add array? I mean, did anyone finish this exercise?
No.
No.
Just started.
Okay. Did you look at this add array? Is there some kind of add array? This is the test add array. So what does this add array means? It's going to add this array recursively. Have you checked this? Not too busy, right? Wife and kids, and no time for that. Anyways, have a look at this one. And we're calling this one, this add array, and this one is calling with this one. Well, basically it's just, you can just call add array with this. So I'm calling with this array. So what does this mean? Array.length, let's simplify this, we use 4. So array.length is going to be equal to what? 4 minus 1. So that's what I'm doing. I'm calling with 3. Why 3? Well, let's see. The last one is, this is going to 3 is going to be into this last. Now let's try to understand how this last is being used, so you can use that last. Now this is add, right? Which means I'd like to add the numbers one by one from the array. So now this is going to be 3. Is 3 equal to 0? No, it's not equal to 0. Now I'm going to call the same method again with the same array, but then I'm going to call it with 2. So basically what I'm doing now, the array with 3 called me the array with 2 plus a.a3. Which one is a3?
The last
0, 1, 2, 3.
1.
So basically I just called the method again, but I just had one value now, and I'm calling it again with this to be a2. So this is going to be what? This is going to be a1 plus a2. Now this a1 is 1 equal to 0? No. So this a1 is going to be calling again a0 plus a1. Now a0, what is it going to give me? Is this equal to 0? Yes, so it's going to call a0. And this is what it does. Like, as an iteration, every time I call the method, I just take one from the list. Every time I take one from the list. So I need to do something similar to that. That's why, I mean, this was given to us. I mean, at the beginning this was not like this, right? It was with this, we just used this a.length. Why? Because they did it in a way. So if you just call the array, and then this one is going to prepare the array to be called in a recursion, and this is the one that is recursive. So how to use this now to our minimum? Yes. Where the what? The add? What do you mean the add?
We didn't add anything. We just read.
Well, if we have this, at the end this one is going to return a0 plus a1 plus a2 plus a3. This is the add, because you're calling the method plus the last one.
We will add the new element.
So you're taking the last one, and then you're going to take the one before the last, and you're going to take the one before the, until you reach 0. Is that okay for everybody? So now, strong with this new idea, let's have a look how we can apply this to the minimum. Now the same idea, we need to make it shrink every time until we reach it. So the minimum of 4 is like the minimum of the last one maybe, and the minimum of the last 3, or something like that. Or we can do it in another way. We can just start from with 2 and then keep increasing. So let's do it the same way that they have done, like something like this, something similar to this. Instead of would like to have the add, we'd like to, I mean, do something similar. So now let's call with the minimum, and the last element of the array is going to be array dot length -1. But for the user who is going to use my method, he has to always, when he calls this method, he has to always do this, right? So it's for convenience. What we're going to be doing, we're going to be doing this like this, and then when the user gives me this one, I'm going to call minimum again. But this time in here, I'm going to put it like this. So I'm going now to focus on the user when he calls the method. He calls it just by giving the array, and that's it. He doesn't have to type something that we type it for him. Now what we need to do is just to have an overloaded method, minimum, that is going to be having like int, like last, if we call it like this. Now in this one, the last, this is the one I need to do something now. Now how can I, to take this example that we just talked about, I cannot find it again. Okay, let's say that this is our array. How does this work now? If we'd like to do it manually and every time take the last. Now we know that the last is this, which means now the minimum of from the array from the beginning until the last is exactly the same as the minimum of this last one with the array starting from 1. So it's the minimum between this and how can I represent that? So the minimum. So I'm going to ask which one is going to be the minimum, something like that, between this one, the 3, or this one. So let me represent that with something like this. So min of this, it should be like the minimum between this one and this one. And this is going to also be like the minimum between 3 and the minimum between 2, and now this one that starts from here. I don't know if you get what I'm trying to say. Now this here, I'd like to get the minimum from this one as well. So the minimum from this one will give me, let's say, so I need to compare this one with the minimum of this one. And this thing, I'm not changing this, but this here is going to be the minimum between now 2, which is the last one again, and the remaining 2 elements. And this remaining and the minimum of these remaining 2 elements. And this is what the recursion is going to be. So every time, do some kind of comparison between a smaller array until I reach a specific time where I need to return just one. This is the minimum. Yes. Now, yeah, there's a mistake here. So now how we do this? First of all, we need to stop somewhere. So when are we stopping? Let's just take this and stop when the last is equal to 0, right? Just because we don't know what to do, we say when the last is equal to 0, we just return the last one. I mean, in our case, this is the first one. Else what? I mean, we don't call it A, we call it array. Else what? We need to return the minimum between, we need to call again minimum of this last -1. But how do I compare this? But then I don't need just to now this is going just to return the numbers and just repeat and stop. There's nothing going to be done. What if when I call it with the minimum that I know of? Now this approach is going to be kind of different from this one. What if when we give the array, we take the first one and we assume that this is our minimum, and then we compare it with or maybe you take the last one. So take the last one and assume that this is our minimum.
Yeah.
And then that's what I'm going to do. Let's say is going to be, I don't know. I need to find some, to put another variable where I'm going to put this is my minimum, and I just need to, when I'm in the last,
Minimum equal array.
so that means this is my minimum. I find it something like that, and then every time I need to call with this, but this time with a different number. But how do I get to do something like this? I need to ask myself first of all, how do I initialize this thing? Now the first value, like here, that I'm going to put, which one? What is going to be the first value? What I can do, no, it's not wise to do anything, but I can do, yeah, I'm initializing with 0, let's say. Now if I'm initializing with 0, I'm going to assume that the first one is the minimum. But then this is not good because if the array length -1, that means I'm just focusing on the last one, which is the last one. Then I'm going to exclude and then go for the next one. So it's better before excluding it just to put this one as a minimum. So instead of putting this 0, let's put the last one. So I assume that now my last one is the minimum. So what does this do? I'm going to, let's imagine, to simplify these things. This is our array, and when I'm calling this with this data, what I'm going to call, this is the array. In this here it should be 4 minus 1, 3, and this one. So now let's call it the last. So when I'm calling this, the last is going to be according to this one. Array.length -1. What is array.length? That's 4 minus 1, that's 3. And array of array.length -1, that means array of 3. So it's equal to what? This is the last value, which is 3. That means our minimum now is going to be 3. And just to, I think, just to get away from the confusion, I'm just going to change that to 13. So it's not going to be confusing. So the minimum now is the last one, which is 13. Now when I'm calling this is what I do. I call this minimum with this one. So the first time I'm going to ask, is last is equal to 0? Then if last is equal to 0, I'm not returning this. I need to check which one is the smallest. The minimum that we just found, or that value from the array. There is this. Now before returning this, I need to do some kind of checking. What I'm going to return basically, when I'm here, I'm going to return the minimum because I would have found the minimum. And before, I need to do something like, if the minimum is bigger than array of 0, then the minimum is going to be array of 0. I just would like to not, well, or I can do what you said, but I just would like to put an if. So either I change them in or I don't, and I'm going to return them in all the time. Now how to make this thing change? Now I need to not return this, I need to call it again. But how do I do that? I call it again, and what should happen before? If, for example, now if I call it like this, this is the array. Let me just zoom in more so I can see it, and let's hide this. Now this is our array, this is our input, the array, the last, the min here. Now is last equal to 0? No. Else, what should I do? Now have this is my minimum. I should now call again the minimum with, now what this does, it will call the minimum with now the array, and last which is going to be 2, and the minimum is not changed. And then is last equal to 0? No. Well, in this case it will work.
So last make it 1, and then make it 0, and then we'll just
Hold on, can I change something just because I don't want it to work? No, sorry, I forgot there's a 4 here. Yeah. So now this is going to, the first call is going to be this. Then the second call will call this, and then I said it will be this. The second call will make this. There's going to be another call which will make this, and there's going to be a last call. It's going to be 0, and then 0. This is the comparison. When the last is 0, it's going to compare 0. This is 13 greater than 12. Yes. So it's going to make this to be 12, and that's it. It will return 12, and this is going to return. And let's put the return here. This is because just to show that this is where it stops. Returns 12, which is not what we want. So what we would like to do, basically, every time before calling to the next one, we need to check if this last -1 is going to be our new minimum. Now this is what I need to do before doing this verification. Every time I get this last -1, I need to compare the minimum if it's bigger than array. Actually it's array with the last, the new last, because this last is going to be, I'm going to compare it with the last one that I just get. Now array of last, yeah, for the first time I'm going to compare 13 and 13. Yeah, I'll just. Now this is the same idea that I did here. I need to do it also here before I repeat. But let's see now what's going to happen. And we're here. I'm going to get inside. I'm asking, is minimum greater than array of last? Which one is array of last? 13. So I'm asking, is 13 greater than 13? No. So I don't do anything, and I'm going to call with last equal -1. Now last equal -1, that means 2. Is 2 is equal to 0? No. 13 greater than array of 2. Which one is array of 2? 20. So 13 greater than 20? No. So I'm going to call last equal to 1 now. And the minimum is still 13. Now is 13 greater than array of 1? Yes. So I'm going to put 4 into the min, and I'm going to call it again with last being 0. Now with last being 0, is last is equal to 0? Yes. Is the minimum greater than a rate of 0? So it's 4. No, sorry, I need to make this. Is 4 now greater than array of 0, which is this 12? No, so I'm not doing anything. I'm just going to return 4. So at the end, after these kind of repetitions, I'll return the minimum. So this is now how this is going to work, and let's try that. So we don't need this. I'm just going to put it back so it doesn't border. So this is our array, and if I run this, I'm expecting minimum to be 1. If I change that, so every time it's going to find the minimum, whatever it is. I'm sorry? If it's a negative, because we always compare. So yeah. If we change the size, it will just run longer before it finds it. Because it starts from here, and then here, and then here, and then here. And this is how to make this in a recursion. Yeah. Yeah, people are getting more and more people down. All right. A lot of fun, right? So this is the find min. Now one advantage of DLL is that it can be traverse backwards while single linked list cannot. However, with recursion you can also traverse a single linked list in reverse because of when you put the call is before or after. Now write a recursive method private void reverse print single linked list node inside the given single linked class to print all the elements in the list in reverse. Okay, where is this file? This is the one. So this is a single linked list, and it has nothing special, just the delete from tail, delete from head, and delete and print all and find. Now I would like to add this print reverse print, and then I mean this is going to be SLL node. Why do we need this? What is this? This is a node. So if I give it a node, it will start printing from that node until the head. And then here in this other one, if I don't give it a node, I'm going to start from the last until the head. So what I'm going to do, this is just like a rule that I'm going to do, and then let's see what the others are going to be. But see, it makes private. Why do it private? I don't know. But let's just. Okay, but we still need to test it, so we'll test it later. So let's make it public because I would like to test it. So I'm not going to make it private. Public. And then from here. So now, how can I print this in reverse? I need to. What should I stop first?
Stop at the head.
So when temp is equal to the head?
Yes.
So when temp is equal to the head, I need to stop. And when I stop, I just print
Print the head.
head.info. And because I'm going to, this is where I'm going to stop, I'm just going to put a space before and then put head.info because I'm expecting the head to be the last one. So I want like to have some spaces before. Now if it's not the head, what should I do?
Just call it again.
Call it again? With what?
Yeah,
How can I make this become recursion? There's no way for me to start. I mean, if I start from the last, there's no way for me to come back because there's no link from the last to the one before the last. The only link that I have is from the head until the last. So what I should do actually, I should put a condition to start from the head until the last. This is where I stop. I stop when it's last. But I'm not going to display until I reach the last, then I'm going to display. So then the temp should be now the last. And when it's the last, there's no last, there's tail. And when I reach the last, then I'm going to display the tail.info. And actually this is the first one that I'm displaying. And then I display the tail and then the space because I'd like to display it in the reverse order. So I'm going to start from the head, go to the tail, and then display when I'm coming back. Now it's easy for me to call this with temp.next. But before or after, when I call now, it starts from the head, let's say. I'm going to go for the next, and then I'm going to print. Print after what? Temp.info. with a space.
For the tail, just there's no need for space.
For the tail, because it's the last one,
Yeah, that's one. There's no need for space.
I'm going just to do this one. When it's the last one, it's going to print and go back to the line. But no, actually, no. This is not the last one. Actually, this is the first one.
We can
Because the tail is going to be the first
we
one.
can- No. We
Space
can
down.
the space before
Before
that,
the temp info.
that info. Not
Before the temp, yeah.
Because
Yeah,
the
and
temp
this-
info will
and
be
for
the
the
last.
tail.
Exactly. So if it's before, yes. Then I put a space, then temp off, because I'm going to display the last, then any elements until that one, and it's all of them going to be print, so we keep them on the same line. And what is this? Exporting non-public type through. Okay. Now I'd like to test this. I'm going to go here, and let's put this into a comment. Oh, you know what? I don't want to do that. I'm just going to, because I need to put some values, and I'm not interested in doing all the code that already exists. So we have single linked list. This is what we've seen in lab 1.
Yeah.
I'm just going to open the lab 1 and get the test file from there. So this is the test with the int, so it's much easier for us to work it here. Okay, there's a test SSL already? No? There is. Where is it?
Yeah.
I didn't see it. Oh, here it is. This is the one I was looking for. So they need to print it. So now that we have this, I just would like to, well, I'll take one. I'm not, no. Yes, okay, let's put a 9.
Instead of print all, we just
Okay, alright. Instead of, let's not change too much. So the print all, instead of doing this print all, we're going to print reverse. But the print reverse is printing from a specific node. Print, reverse print. So reverse print, but we need to give it from where we start. So there's no, let's give it the tail. So we always, this is like basically, you know what, it's like this one. I'm going to, and this is why they made this, that one to be here, to be private, because they didn't want to do that, because the one that is public is going to be calling the one that is private. And this is why they made this reverse print without nothing, and this one, if I call it with nothing, I'm going to call the reverse print because I need to start from the head. So I'll start from the head, so it's going to print from everything. Even the other one, that's not the tail. I'm going just to remove this. Now this is private, so if I just call reverse print, it will print them in reverse. Now it's just shift F6 to run this file. Okay, let's just well, print all, there's nothing in it. I need to put something first. So I'm going to put 1. This is add to the head, right? So I'm going to add to the tail so I don't get confused. 2, and then 3, and then 4. So now I'm having 1, 2, 3, 4. If I print them in reverse, four, 3, 2, 1, and that's the reverse print. So it works, and that's the end of it. Update the given blah blah blah. So that's done. So as you can see, a lot of fun with this recursion thing. It's not complicated that much. It's a little bit of complexity,
more time.
but it takes definitely more time to find the answer. But again, I didn't want to show you the code and discuss that. That's why I prefer this way, to show you the steps, how to find problems, and then when we I generally did not see, I did not solve this problem before. I'm just solving it with you, because I want you to see the steps that I'm doing to try to find the solution, and so you can build the answer, not just try to understand the answer.